The video is about image formation of lenses using ray diagram. Now the lenses are convex lens and concave lens. Concave lens is also known as converging lens, and concave lens is known as diverging lens. Once again I am repeating, convex lens is also called converging lens, and concave lens is known as diverging lens, because concave lens converges the image at a point, but concave lens diverges the ray parallel to the principal axis. So this is the difference. Now, so the first ray that will pass parallel to the principal axis in case of convex lens will converge at the focus on the other side of the lens. Okay. I will show you the figure, but you listen me first, Nalika. Once again I am repeating, a ray parallel to the principal axis in case of convex lens will pass through the focus on the other side of the lens. Okay, will pass through the focus. But in case of concave lens, a ray parallel to the principal axis appears to diverge from the focus on the same side. Okay, a ray, once again repeating, a ray parallel to the principal axis in case of concave lens appears to diverge from the focus on the same side. It is, as I am showing you the figure, see, this is convex lens, this is convex lens, because this is the ray parallel to this is the principal axis, and O is the optical center. Okay, it converges at the focus F2. You can say the secondary focus, you can say, on the other side of the lens, right? But in case of convex lens, this is convex lens, a ray parallel to the principal axis diverge in this way. Okay, but when it produce backward, it will meet at the focus. It is here, F1, the same side. Okay, this is the ray parallel to the principal axis diverge in this way. It is here, but appears to come from F1, from the focus. It is coming from the focus here now, here at this point. Okay, therefore concave lens is also known as diverging lens, and this convex lens is called converging lens. So all the ray coming from infinity, okay, parallel to the principal axis will converge at the focus in case of convex lens, and in case of concave lens they appear to diverge from the principal axis, from the principal focus located on the same side of the lens. It is, because this appears to diverge from the principal focus. Here F1 is called the principal focus. It's okay. So all ray parallel to the principal axis will converge at the focus in case of convex lens, but appears to diverge, okay, appears to diverge in case of this concave lens, and it appears to diverge from the principal focus. This is the principal focus here. Okay. So this is the difference in the ray diagram of these two lenses. Okay, yeah. Now I will show you some more figure. Now, concave lens, concave lens, it always makes virtual image. It always makes virtual image. Always makes virtual image. And you know virtual image is that which is erect, जो सीधा रहता है, that is erect, and it will form on the same side of the object. Okay, the image formed by concave lens is in the same side of the object. Okay, when the ray is coming from the infinity, okay, the image will be formed on the focus in the same side, and that is why it is virtual. Okay, other images, I'm talking about concave lens, other images, okay, will form in between focus and the optical center. In lens, the middle of the lens is known as optical center. You know, in case of mirror, that was known as pole. The center of the mirror was known as pole, P-O-L-E, pole. So did you follow? Okay, in case of concave lens, the image is always virtual. Virtual images are erect one. It is erect, right? And it will be diminished one, छोटा बनेगा. और कहाँ बनेगा? या तो फोकस पे बनेगा या फोकस और ऑप्टिकल सेंटर के बीच में बनेगा, सेम साइड बनेगा, इसलिए वर्चुअल हो गया. जिधर ऑब्जेक्ट है इमेज का फॉर्मेशन भी उधर ही होगा, आपके पीछे साइड नहीं होगा. नाउ lenses are transparent, isn't it here? But the image formed by concave lens is same side as the object is. So clear? So image formed by concave lens is virtual, always it is virtual. Now, in case of convex lens, the image formed is real and virtual also. Okay, wherever you will keep the object on the principal axis, the image will be real one. It will be the other side of the lens. It will be erect. It's okay. But in case when the object is kept in between principal focus and the optical center, in this case only, convex lens makes virtual images. Right? It makes virtual images. In only one case it makes virtual images, right? On the same side of the object. Clear? Let me repeat it once again. In case of convex lens, the image formed is real one. But in only one case, it makes virtual image when the object is kept in between the principal focus and the optical center. In this case, the image formed is in the same side of the object, and it is virtual and it is highly magnified. Okay? So is it clear? I think it is clear now. So now let me show you the image formation of an object when the objects are at infinity, then beyond C, you know, center of curvature, then at C, then between C and F, then on F is the focus, and then between F and O is the optical center. So this, the ray diagram of this, I will show you. Ray diagrams I'm showing you. So first of all, when the object is at infinity, what happens? See, this I am doing of convex lens. Principal focus, the object, and this is the convex lens. A ray parallel to the principal axis, you know, always converge on the focus. It will converge on the focus. It is like this, It's like this. A ray parallel to the principal axis will converge on the focus. It's like this. So this is F. Clear? So this is the mirror, this is the lens it is. This is Mn is the lens, and AB, suppose it is AB. This is C. No, in case of this infinity, it is object at infinity. Object at infinity. Then the image formed is on the focus. It is diminished and real one. And on the other side of the lens, see here now. See, this is the figure. This is image is coming from infinity. This is the lens, convex lens it is, and all the rays are converging at the focus. Okay, F2. That is the secondary focus. You can see on the other side of the lens. This is the one side. This is that's the opposite side of the lens. So the image is on the focus, small one. Clear? Yeah. Shall I write here now? Okay. So the object, I'm writing here now. So when the object is object at infinity, image on F focus, small in size, smaller in size, a real one it is, it's correct, like this. This is object at infinity, image on the focus, smaller inside, and it is a real one. Okay. Now the second. Now let us keep the object at beyond C. You know C. What is C? That is the center of curvature. Let me draw the principal axis and the lens in between. And this is F1. This is C. This is F2. This is C2. C1, C2. C2 is also or C1 is also is double of the focus. C is the center of curvature. So let me keep the object at beyond C. Then one ray you have to draw passing through parallel to the principal axis, and that will converge on F2. F2 is the focus, secondary focus. You can see like this. It is okay. The next. Now what next is that one ray will have to pass through the optical center. Optical center, when the ray is passing through optical center, okay, it passes a state without diverging. It will be like this. So this is AB is the object, and A and B here now. A dash, B dash. Dash means image. C. Okay, the object is at infinity. This is infinity. The rays are coming parallel to the principal axis. This parallel ray is passing okay, to the other side of the lens through focus, secondary focus you can say, or simply focus you can say. The second ray I have drawn passing through the optical center, a ray passing through optical center will pass without diverging. Okay, it will not change its path, so it is passing straight, and they meet at, okay, in between F and, okay, in between F and C. The images, the two ray diagrams here, it is meeting here now. Okay, this is meeting here now, this is meeting, this is so meeting, so that is the, okay, place of image formation. And look here, the image is small, it is inverted, it is below the principal axis, and the object is on the axis, but image is on the principal, okay, below the axis, so therefore it is real. Okay, it is a real image, real diminished, and on the other side of the lens smaller in size. Okay, right, this is. So let me write the conclusion about this object at C. Object beyond C, yes, it is beyond. Object beyond C. Object beyond C. C the center curvature. Then image. Image is in between. Is in between F2 and C2. C2 is also known as twice F2. Okay, it is smaller in size, okay, and the real one, it is a real inverted. Real images are always inverted, so this is C, just C. This is, I have concluded here now. Okay, now let me keep the object on C. Okay, C, it is on the C. What is the center of curvature? So this is the principal axis. This here. This is F1, C1, F2 and C2. So object is kept at C. C is the center of curvature. Okay, it passes parallel to the principal axis, like this it is. Okay, it will pass through the focus. It's like this. Then one ray you draw, okay, one ray you draw to the optical center, it will pass undeviated. So it is like this. So the image formed here now is on the C only, on the C. Okay, see it is here. It is of the same size, the real one and inverted. The image formed is at C2. The object was at C1 and the image is at C2 on the other side of the lens, and it is below the principal. The image is below the principal axis. When the object is on the axis, means above the axis, then the image is below the principal axis. So it is like this. Look at MN is the lens, O is the optical center, right? And this is F1 is the principal focus. This is the C1 equals this is known as central curvature. The same way here, F2 here now the secondary focus, and this is center of curvature here now, this one. Look at the image formed is at the center of curvature, C here, this is also C here now. Okay, C. the object is in between, the object is at C, the object is at C here, ये C पे है, ऑब्जेक्ट C पे है, इमेज भी C पे हो गया। तो जब C पे होगा सेम साइज का होगा, रियल होगा, छोटा होगा, ओके, छोटा नहीं सेम साइज का होगा, ओके, और रियल होगा, ये इन्वर्टेड होगा और लेंस के अदर साइड में बनेगा। क्लियर? नाउ नेक्स्ट इट इज between F and C, between F and C, between F and C, between F and C, see what happens. Draw one ray parallel to the principal axis. It will pass through the focus. It will pass through the focus. It's okay. Now, A main is the lens. Then you have to draw one more ray passing through the optical center. Passing through the optical center. So you draw one ray here now passing through the optical center. It's okay. This is so. AB is the object. Just like this. See here diagram. AB is the object on the principal axis, and the image formed is A dash B dash. It is A dash and the B dash, and it is real one inverted. It's correct. A main is the lens. It's clear. So let me conclude. Now object at in between, no? Yes, in between. In between F and an optical center. Yeah, O is for optical center. So what we get now here? Image. Image is this. Image is beyond. Image is beyond C. Okay, large, magnified. You can say this is the word used in physics. Magnified. Magnified. Secondly, it is real one. Real one and inverted. You know, a real one are always inverted. So this is my conclusion. This is a conclusion. Now let me keep the object at F. Okay, let us keep the object at F. So when the object is kept at F, the image will move to infinity. It's okay. Will move to infinity. It's like this. This is principal axis. This is F1, C1, F2, C2, C2. Okay. Now keep the object at F. चलो A पे रखते हैं इसको object को. So as usual, you have to draw one parallel line to the principal axis. It will pass through the focus. It's like this. Okay. Then draw another ray passing through the optical center. It will be like this. It is just like this. What do we see that the refracted ray are parallel to each other. This is parallel to each other. They will not meet anywhere. But the parallel lines are supposed to meet at infinity. Okay, the parallel lines seems to meet at infinity. Therefore, the image form will be at infinity because they are parallel. It's clear? They are parallel. That's why. This is important question. Now, yes. So let me conclude here now. So, object at f now image is at f is the focus. Okay, image is at infinity. Image is at infinity. Image infinity पे होगा. Now magnified the real one, the real. Okay, it is real. It's real. So this is the conclusion. Watch it. Excuse me. Now again. Till now, all the images were till all the images. The last ray diagram is when the object is kept in between F and O optical center. Okay. In this case, the image will be on the same side of the lens. Okay, and that is virtual, highly magnified. This is the only one case in which the convex lens makes a virtual image. Okay, and the ray. Just I'm explaining, showing you here now. See this is the object. The object is this one. This is the object here between F and O. One ray is parallel to this principal axis. It passes to the focus. Next one I have done passing to the optical center. This optical center. So this is the ray done to the optical center. It's okay. Now look at these two rays. These two refracted rays. This ray and this ray. This ray and this ray. This ray and this ray. They are not parallel. Okay, so they will not meet anywhere. Okay, they are not parallel, therefore they will not meet anywhere. Therefore we have to extend the ray in opposite direction, in the same direction of the mirror. Look at it. It is this. Two rays have been extended in the same, in same side of the lens. It is like this, and this is the virtual image. A dash B dash is the virtual image. A dash B dash is the virtual image. Right? And this is the object. So the image is virtual one, highly magnified, and it's on the other side of the lens. So this is all about image formation by convex lens. Okay. So let me conclude this one. In this case, now object between F1 and O is optical center. Then image is on the same side of the lens. Same side of the lens का मतलब है जिधर ऑब्जेक्ट था उधर ही इमेज हो गया. ओके, जिधर ऑब्जेक्ट था उधर ही इमेज फॉर्म हो गया. सो दिस इज virtual. Okay, and highly magnified. Highly magnified. It is highly magnified. It is highly magnified. Just see. This is. Just see here now. This is highly magnified. So I think the video has gone long, isn't it? Here, the video has gone long. It's 30 minutes now. It has gone over. It's okay. I hope you will enjoy, and in the simple way I have drawn the ray diagram, and watch it. Okay, thank you.